chapter in mechanics. The name of the chapter is Centroid and Center of Gravity. Here we have the first part is Centroid, and the second part of the chapter is Center of Gravity. First, let us understand what is Centroid. Here I will be writing the definition of Centroid. Centroid, it is a single point about which entire area is acting for a lamina or plane figure irrespective of of the plane. So here I have written the definition of centroid. By centroid we mean that it is a single point about which the entire area is acting for a lamina or plane figure irrespective of the position of plane. So from the definition, it is understood that centroid is applicable only for plane figure. And when I talk about plane figure means only 2D figures, no 3D figures. So here I can see that plane figure having area but no. So here I have clearly defined what is centroid. When you talk about centroid, you are talking about a figure which has area but which has no volume. So by no volume, it is clear that it is not a solid but a fluid. Examples: some of the fluid figures are rectangle, square, circle, triangle, quadrilateral. So here I have given some of the examples of plane figures. Whenever we will calculate the centroid, we will be calculating the centroid only for these figures. Or if it is possible, you can combine, like for example, you can combine rectangle and figure, then it becomes a composite figure. That is called as a composite figure. Composite figure is that figure in which you are having more than one plane figure. So if you have two plane figures, it becomes a composite plane figure. And if you can even go on increasing the number of plane figures. Minimum two are required. So from this, here it is very much clear about the centroid, the definition part, that it was for the single point, the entire area is acting on a lamina or plane figure, irrespective of the position. Irrespective of the position, even if you go on changing the orientation, like for example, if there is a triangle, we are having the apex at the top, even if the apex is at the bottom, then at that time also the centroid will not change. It is a point constant. Now let me draw a diagram which will indicate, which will explain you the concept of centroid. Let me consider a plane figure which is of any general shape. Now this figure which I have, it consists of small areas. Here there will be Now, small small areas will give us the total area, denoted by capital C. Now, instead of having individual areas, if I want to denote the total area at that single point would be called as the centroid. So here, if I draw this thing, instead of showing individual areas, I will be showing the total area by one particular point, and that point becomes centroid. Centroid is denoted by letter C, and the location of the centroid with respect to y-axis, it is x bar, and the location of centroid with respect to y-axis, with respect to y equals x bar, with respect to x-axis, the distance of the centroid is y bar. So in other words, here we have a single point which is denoting the entire area. Instead of showing area on individual points, we show area on one. That single point is nothing but the centroid. So here, the letter G which I have written indicates the centroid. So it is very much clear from this concept of centroid that if we want to locate the centroid, it would be located by finding the values of x bar and y bar. X bar, y bar are the coordinates which give us the centroid. And in this chapter, we will just locate the centroid. So with this, I think the definition part and the concept it might be understood. In this video, we will be solving the problem of centroid. Yes, we have a question. We will be solving the problem of centroid. Yes, we have a question. I'm going to mark this question. Let's read what is given here. Find the centroid for a detail having flank 120 and width 180 mm. Now this is the question in front of us. Let us try to find the solution. Here the centroid. Centroid we have to find out. Then we have to calculate what are the values of x1 and y bar. So we have to calculate what are the values of x and y bar. Before that, I will draw the now here we have a T section where the flange is 120 into 12. 120 mm into 12 mm. Width is 180 mm into 18 mm. So 180 mm is the height of the width. 18 mm is the width. So here we have a upper portion is called as flange. And this vertical portion is called as width. Now, as per the dimension given, flange is 120, width is 180 into 18. We have to find the centroid. Centroid For that, what we have to do for this, we don't have a direct formula. It's a Centroid for it. So how to find the Centroid of a the simplest way is to divide this section into two rectangles. So here we are having two rectangles. I thought this is rectangle one. And I would for rectangle number one, yeah, it's my value. This is a full and this minus one side. Here I'll say that yeah, one point comes up to 1,240. If I want to calculate for the first rectangle, now what is x1? X1 is the location of y for the first rectangle. So the y-axis for the first rectangle at half of 120. The y-axis for the first rectangle, the value of x1 minus rectangle 1 starting after 1. Here I define the y1 first rectangle. Now the x-axis for the first rectangle is half of the 180 times half of therefore y1 comes out to 1. Now after getting x1 and y1, I will calculate since a2 is equal to a2 is for and it is 18 into 180. Area 2 comes out to be 3,240 mm square. Now after getting area 2, I will calculate the value of the y-axis for and we can see the y-axis for their part for their half of next we can calculate the value of y2. Now y2 will be since the second rectangle is having height of 180 mm. So the x-axis for the second rectangle will be at half of 180. So therefore y2 is equal to 180 divided by 2. So that is 9. Now once we know all the values, and we can multiply them with respect to y-axis, that is called as x1. Therefore, I put all the values here. A1 was 1,440 into x1 Y bar with respect to x-axis, that is y bar equal to 1 minus 2y2 upon the 1 plus. So here is the formula for y bar. Now I put all the values here. Area 1 is 1240. Y1 for 186 plus the 2 that was 3240 into y2 90 divided by the 1 plus the 2. For y bar value comes out to 109.5. The second answer. Now after getting x bar and y bar, we can locate them on the D section. Here I draw the D section again. Flank was 120 mm and the height was, it was 12 mm for flank. For web, the height was 180 and the width was, after this we would be locating x bar and y bar. Bar comes out to 2 and half of 120 we are getting x bar and y bar is 119.5. So here is the centroid which I am denoting it by letter G. X bar and y bar are the coordinates of the centroid. X bar distance y bar 119.5. So once we have given the coordinates then bar and y bar we have to give centroid and centroid is that point where the entire area of it would be acting. Hello friends, here in this video we will see a problem on calculation of moment of inertia for a C section, and for that here we have a question. Hello friends, now we will take the problem of centroid. Now we will take the problem of centroid based on C section which is given in the problem. So in this video we would be locating the centroid for a C section. Let's read what is given in the question. The question is, locate the position of centroid for a channel section as shown in figure. Here the diagram is given. As we can see here, a C section, or in other words it is also called as channel section, it's given. The dimensions of the channel section are given. The question is to find the position of centroid. And when we say position of centroid, it means we need to calculate x bar and we need to calculate y bar. So, in order to get the centroid for the C section, the first thing is we would be dividing the C section into three rectangles as I have divided here. Here I have divided it into first, second and third rectangle. Now after this, let us start with the solution part. Here I'll say that since area 1 indicates area of first rectangle. As we see, the first rectangle is here. It will be having the dimensions since this width of the rectangle from, we can say, at this region till here it is given as 1000, and from 1000 if I subtract 200, that is the width of the wave given here, so 1000 minus 200 will give me 800. So this much portion from here till here for the first rectangle, it is 800. So I draw the first rectangle. So here we are having a rectangle of width 800 mm and height as 200 mm. The first rectangle. So area will be 800 multiplied by 200. That comes out to be 16 into 10 raised to 4 mm. After getting area, here I will calculate x1. x1 is nothing but the location of y-axis for first rectangle. Here, if we have the rectangle number 1, its y-axis will be passing exactly at half of 800. So this distance is 400 mm. So it is 400 from, we can say, if I can show you in the diagram, it is 400 from this distance where we have separated the rectangle. But as we know, in case of centroid, we are taking the reference as x and y axis. So I have to measure the distance from y axis. So from y axis, this will be 200 plus 400, because here we are having at 400 the y axis for the first rectangle. So that becomes 200 plus 400, this gives me 600. Now after getting a1 and x1, now I will find y1. y1 is the location of x-axis for the first rectangle. X-axis for the first rectangle, it would be located at, since we are measuring the distances from x and y, here my reference would be x-axis. So from x-axis, I take the distance. First rectangle is starting after 200 plus 1600. So it is 200 plus 1600 mm plus the x-axis for rectangle number 1, it will be at half of 200. So it is 100. So y1 will be 1900 mm. Now, after getting these values, that is a1, x1 and y1, similarly I will calculate a2, x2 and y2. For that, I will draw the second rectangle. Now this second rectangle is having width 200 and its height is 200 plus 1600 plus 200, that is 2000. So it is 200 by 2000. This is the second rectangle. Its area will be 200 into 2000. That gives me 4 into 10 raised to 5 mm square. Next, x2 will be equal to, x2 is the location of y-axis for the second rectangle. And since we are measuring the distances from x and y, here I'll say that y-axis of the second rectangle would be exactly at half of 200 if we measure it from y-axis. So x2 is equal to 200 divided by 2. That is 100 mm. Then y2 represents the x-axis of second rectangle. That will be exactly at half of the total height. So as we can see here, rectangle number 2 is having its height as 2000. So its x-axis will be exactly at half of 2000 from x-axis. So it is 2000 divided by 2. So that is 1000 mm. Now once we have A2, X2, Y2 also, I will also calculate A3, X3 and Y3. Now since rectangle 1, rectangle 3, they are having same area. So here I will draw rectangle number 3. The width of rectangle 3 is 800 mm and its height is 200 mm. This is the rectangle number 3 having the same dimension as rectangle 1. So therefore, area 3 is equal to 800 into 200, 16 into 10 raised to 4 mm square. X3 is the location of y-axis for third rectangle. Again, this y-axis will be at half of 800, that is 400 mm. And if we take the distance from the origin, then it will be 400 plus 200, that is 600 mm. Y3 will be the location of x-axis for the third rectangle, and this x-axis will be at half of 200, that is 100 mm, because if we look into the diagram for the C section, rectangle number 3 is lying on x-axis. So if I take the x-axis for the third rectangle, its distance from the x-axis will be half of 200. Now after getting all these values, we can easily go to find x bar and y bar. I'll say that since location of centroid with respect to y-axis is given by x bar is equal to a1 x1 plus a2 x2 plus a3 x3 upon a1 plus a2 plus. Now we have to put all the values here that I will write on the next page. So therefore, x bar will be equal to a1, the value is 16 into 10 raised to 4 into x1, it is a1 x1, so x1 is 600 plus a2 x2, a2 is 4 into 10 raised to 5, x2 is 100 plus a3 x3, a3 is 16 into 10 raised to 4, x3 is 600 divided by area 1 plus area 2 plus area 3. So from this, if I calculate, I will be getting the x bar value as, it comes out to be 322.22 mm. This is our first answer. Similarly, location of centroid with respect to x-axis is given by y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a. So here I'll put the values on the next page. Therefore, y bar is equal to a1 y1 and the value of a1 y1 is a1 is 16 into 10 raised to 4, y1 is 1900 plus a2 y2, a2 is 4 into 10 raised to 5, y2 is 1000 plus a3 y3, a3 is 16 into 10 raised to 4, y3 is 100 divided by area 1 plus area 2 plus area 2. So from this, if I calculate, y bar value comes out to be 1000 mm. This is the second answer. Once we have got x bar and y bar, we can easily show it onto the diagram. So here I would be marking the centroid or the C section given. Now, x bar value is 322.22 mm and x bar is the distance with respect to y-axis. So first, I'll keep this C section onto the x and y system. So the y-axis is at 322 and x-axis, it would be at a distance of 1000 mm, exactly at half. And this intersection will give the centroid, that is the intersection of x and y axis. And once we have located the centroid, we can easily say that the problem is over and hence we have completed the location of centroid for the C section. In this video, I will be solving the problem of centroid. Let us In this video, I will be solving the problem of centroid. Let us take In this video, I will be solving the problem of centroid. Let us take the question number 1. I'll read what is given here. Find the position of centroid for an unequal angle section with dimension 150 mm into 200 mm into 10 mm and the longer leg is 40. This is given. So let us try to solve this problem. The solution part. We have to find the position of centroid. By position of centroid, we mean that we have to calculate x bar and y bar value. So the angle section is given. It is unequal angle section. And the dimensions are given. So I draw the unequal angle section first. Now, Dimensions are 150 into 200 into 10. 150 is the width, 200 is the height, and 10 mm is the thickness of this unequal angle section. 150 mm is the width, 200 mm is the height, and 10 mm is the thickness. Now, this is the angle section given. Here we are saying longer leg is vertical. So if we see for an angle section, we have 150 mm leg and 200 mm. So out of this 200 mm is the vertical leg. Because it is the longer leg, we have to keep it as vertical. For this angle section, which is unequal, we have to locate the centroid. That is, the question is find the position of centroid. So for the position of centroid, we have to calculate what is its bar and what is y. So these are the questions. Now let us try to solve this. We are solving the problem on centroid, and now the figure is an angle section. And we in the formula which we have written for the centroid is that we don't have any direct formula to calculate the centroid for angle section. So what we can do here, we will divide this unequal intersection into two rectangles. Now I'll say that this vertical rectangle, I'll call it as rectangle 1, and the second one I'll call it as rectangle 2. So now I will calculate first the area of rectangle 1. I'll say that since area 1 is equal to this 10 multiplied by 200, that is 2000 square. Now after getting area 1, here I will calculate x1. x1 means for the first rectangle, where will be y? The y-axis for the first rectangle will be at half of 10. So here the y-axis which I will be getting for the first rectangle, the distance of that y-axis with respect to the original axis which we have here, that will be x1. x1 becomes half of 10. That is 5. Therefore, y1 will be equal to. Now y1 is the distance of x-axis for rectangle number 1. For rectangle number 1, its x-axis will be at half of 200. So y1 is the location of that x-axis. So 200 divided by 2. So that is 100. Now this much we have to write for the first rectangle. Similarly, I will be calculating area x1 and x value and y value for rectangle number 2. So now I'll say that similarly, area 2 is equal to the second rectangle is having width. Here this was 150 from the origin up to the angle section. Now, if I minus 10 because this is for the first rectangle, then I will be getting the width of the second rectangle. So it is 150 minus 10, that is 140. So I will draw the second rectangle here. Now, for second rectangle, area will be 140 into 10. That is 1800 mm square. X will be equal to, now x is the location of y-axis with respect to origin for second rectangle. For second rectangle, the y-axis would be here, that is exactly at the half of its width. Now width is 140. So 140 divided by 2 will give 20 plus 10, that will give the distance of the y-axis for second rectangle from the origin. So it is 10 plus 140 by 2, that becomes 80. Then y2. Y2 is the distance of x-axis for second rectangle. That will be exactly at the half of the height. Height is 10, so the x-axis will be at half of 10, which means we have got the distance y2. So y2 is half of 10. Now after getting these values, we can easily calculate the value of x bar by 1. For x bar, I'll say that this the location of centroid. X bar is the distance with respect to y, the location of centroid with respect to y axis is given by x bar is equal to k1 x1 plus k2 x2 upon area 1 plus area 2. We are into area here. Now I put the value k1 for 2000 into x1. X1 was 5 plus area 2 that is 1400 into x2 that is 80. That is the area 1 plus area 2 that is 2000 plus from this if I calculate I will be getting the value of x bar. So x bar is equal to 35.883. My first answer. Now I will calculate y bar, and y bar is the location of centroid with respect to x axis. So the location of centroid with respect to x axis, that is y bar is equal to a1 y1 plus a2 y2 upon area 1 plus area 2 is equal to area 1 that was 2000 into y1 value we have calculated it is 100 plus area 2 that is 1400 into y2, the value of y2 we have found out it was 5 divided by area 1 plus area 2, 2000 plus 1400. From this we will get the value of y bar. Y bar is 60.88 mm. The second answer. Now once we have calculated x bar and y bar, it means we have located the centroid, and now I will locate the centroid for this unequal angle section. Here is the unequal angle section which was given in the problem. This is an unequal angle section. Now I locate the centroid for this. So here we have located the centroid, and in the bracket I will write the coordinate. Coordinate should be well shaped in the form of x bar y bar. X bar value was 35 point. And y bar value is equal to distances they are measured with y axis and x axis is where centroid on unequal angles. So we have found out the position of centroid for unequal intersection, calculated the values of S bar